Hello class, today we'll be starting with a new unit which is unit 1.7. In this unit, you will learn about energy, work, and power. The first part of this unit is about energy and work, and these are the lesson objectives that we will go through for this video lesson. Now, what is energy? Before we talk about what is energy, it's useful to think what happens when there is no energy. A car cannot run without energy from burning petrol. Your body cannot move unless you have energy from food. These are some examples of what will happen if there is no energy. When we have energy, we can do things. And usually, doing things mean that there's motion being produced. When you have energy, you can move things, you yourself can move, and other things can move as well. When there's no energy, there's no motion, there's no movement. So, what is energy? Energy is the capacity to do work. If you have a lot of energy, you have a lot of capacity to do work. If you have no energy, you don't have any capacity to do work. You don't have the ability to do work. The SI unit for energy is joules. Joules is named after a scientist with the same name. For example, lifting a glass of water from a table to your mouth requires about 1 joule. Now, talking about energy, we can talk about work. So, work is something that you do when you have energy, and energy is needed to do work. Work is done when a force produces a motion. So, that makes sense. Whenever you're doing work, what you need to do is you push something or you exert a force on an object, and that object moves. Whenever there's a force involved and there's movement involved, we can usually say work is done on that object. For example, pushing a box or lifting a book from the ground. Work can be calculated using this formula. Work done is equal to force times distance. And the distance is very particular in this case. The distance that we mean here is the distance moved in the direction of the force, and we'll talk about this later. Work is something that comes from energy. It also has the same unit of energy, which is joules. Bear in mind that when you write the unit for energy, you have to write it down as capital J, not as small j. Okay? So no small j, capital J is the way to write it. Let's do an example. Here I have a box pushed horizontally over a distance of 4 meters with a force of 3 newtons. Calculate the work done. So what's the formula for work? Work is equal to force times distance. And the force in this case is 3. And the distance moved by this box is 4. And the work done for this case is 12. And the unit is joules. And that's the answer. Let's do another example. A block of wood is placed on a rough horizontal surface. So let's draw that really quickly. So this is the wood on the rough horizontal surface. The frictional force between the block and the surface is 4 Newton. So we have friction here of 4 Newton. A girl gives a force of 10 Newtons to pull the wood for 1.5 meters. So you have a girl here that's pulling the wood at a force of 10 newtons, and the wood move by a distance of 1.5 meters. Calculate the work done by the girl. Now there are two forces here, which is the friction force and the pulling force. Which force should you do for the formula of work done? So work done is force times distance. Which one do we use for the force? Now the force is the force exerted by the object or by the person doing the work. So in this case, we are using 10 newtons. So the force in this case is 10 newtons, and the distance is 1.5 meters. And the answer to that is 15 joules. Example 3 this time. So how much work is done to push the box in the diagram below? Just like before, we use the formula for work done. And the force in this case is 50. What about the distance? Now you have two distances here. Here 30 meters and 40 meters. Which one do we use in order to calculate our work done? Now if you remember from the slide previously, When we're talking about work done, the distance that is being produced when doing the work has to be in the same direction of the force. So in this case, which distance do we use? It's actually this distance here, because this distance is the same direction. The force is in this direction. This distance has the same direction. In other words, it's parallel to the force. So you have to find out this distance here. So in order to find out this distance here, now this looks very familiar. This has a triangular shape, and this distance is the hypotenuse of this shape right here. So from your maths classes, the hypotenuse of a triangle, so you learn this is trigonometry in maths. So how do you find the hypotenuse of a triangle? You use this equation of c squared is equal to a squared plus b squared, where this is a, this is b, and this will be c. Okay, so c squared is basically d here in this case. That's what you want to find, the hypotenuse itself. A is 40 squared, b is 30 squared, and in order to find d, I'm running out of space here, is 40 squared plus 30 squared. D is equal to, so now that we know d is 50 meters, we can find out work now, and work is equal to 2,500 joules. Right, so very important for you to know that for work to be done, the force and the distance moved must be in the same direction. All right, so in this first case here, the direction of the force is to the right, and the object is moving to the right. So is the person doing work on that object? The answer is yes, because the force and the direction of the motion is in the same direction. What about this person here? This person is carrying the bag, and she is exerting a force upwards on the bag, but she is moving to the right. So in this case, is she doing work on the bag? In this case, no, she's not doing work on the bag. What about this case here? Trying to lift a grocery bag? Is she doing work? Yes, in this case. And lastly, here she is carrying the grocery bag, but she's moving in a direction that is not in the same direction as the force she is exerting on the bag. So in this case, she is not doing work on the grocery bag. You make sure you be careful when you are looking at force and the direction of the motion of the object of which work is done on. So here's a summary of everything that we looked at today. For your lesson objectives and for your exam, you need to be able to define what is energy. Energy is the capacity to do work. You need to be able to define work done, and that means that you need to be able to state the equation for work done, and that is force time distance. Set the unit of energy and work done, and that is joules. For part 2 of this unit, we're going to be looking at the forms of energy, or otherwise known as the types of energy.